Alright, welcome back. Today we'll be solving a LeetCode problem called find the index of the first occurrence in a string. It's marked as easy. 4.6 thousand likes, 234 dislikes. It's quite simple. Given two strings, needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. Example 1. Input, so we write here, input being haystack being equal to the string sad but sad, needle being equal to sad. The output is 0, and we have a little explanation right here. Sad occurs at two indices, 0 and 6. The first occurrence is at index 0, so we return 0. Here's an example where we have a string and a substring, but the string does not contain the substring, therefore we return -1. We have a few constraints here, and that's neither here nor there, it's not important to us. Before we actually go into building a solution, let's just go look at the discussion section, which I suggest you do after building your solution. I just want to look at it because I think it's a little funny. So, who marked this as easy? It's not easy at all. Though, you can easily produce OMN, so that is order of runtime, O in difficulty. I forget what O stands for, but anyway, MN solution. It's not accepted by Python. You need KMP algorithm, a KNP algorithm, okay. And then there's, I don't think they meant that I can call a library function. Also, I get a time limit exceeded on a brute force. So this means I should use an advanced algorithm, like a Rabin-Karp or KMP. I'll be honest with you, I've never heard of the Rabin-Karp or KMP algorithm. So why is this problem marked easy? A lot of hate from this, or to say what it is, a lot of confusion from this dude. And then there's Tlong 1299, use find. As a Python programmer, if you're using to use core language features is akin to using a hammer instead of a nail gun because it makes you a better carpenter. Remember that this is Python, not C. Python's PEP20 states this should be one, and preferably only one obvious way to do it. I would call a string operation built into Python, designed to solve this particular problem, the obvious way to do it. Don't use find. Okay, I'm not going to get into this, but I want to show you guys something. Let's go into my first submission, which is this one here. This is in C++, but equivalently, Python has a very similar function. All I did was haystack.find needle. So what this says is string1.find substring. If it's found, return the first index. If it's not found, return 0. And we notice that it has a runtime of 0 milliseconds and a memory usage of 6.4 megabytes, beating 26.68%. And I would have left the problem here and decided to find a different solution on my own that I would not have submitted. But then I came to the conclusion, there's nothing wrong with using built-in functions and types. Here's the thing, unless stated explicitly that you shouldn't use something, use it. It is not your fault that the description of the problem does not state do not use a pre-built function. If the argument is do not use that which already exists, okay, just stop programming then, because everything that you are using has already been built by someone else or a group of someone else. So let's actually consider a solution where we do not use the find function. I have 4. This is my best one. A runtime of 0 milliseconds and a memory of 6.2 megabytes beating 94.64%. Let's go ahead and start building it. So I already have my C++ main file opened and a few test cases. So string needle need, Neil and need with need, Mississippi with is sip, and then just the problem description right here. Let's go ahead and build it. You just first create the function name. Needle, right? Then int letter matches. This just determines if needle does occur within haystack. We'll use it as a counter. So used as a counter to determine if needle is a substring of haystack. All right. What are we actually trying to do here? What we're trying to do is, given a string, let's say needle, we are trying to determine if another string, such as need, appears within needle. How do we do this? We grab the first occurrence of, let me just give these a little, so let's just call this haystack, let's call this needle. What we do is we grab the first character within haystack, so n. Once we grab n, we are trying to find X amount of letters from the first char that we just grabbed, where X amount of letters refers to the length of needle. So once we grab the first letter of haystack, we will then read into needle, reading up to 4 letters. N, does n match with n? Yes. So we will then grab the second letter of haystack, E. Does E match with E? Yes. Again, does E match with E? Yes. Does D match with D? Yes. At this point, letter matches will now be set to 4 because letter matches equals 4. We can say that the substring does indeed occur within the string, therefore return the index. Else we return -1, -1. That's the logic behind the code. Quite simple. So what we have to do is loop over for int I. This is the index. So for int I, actually let's be more descriptive. Let's say for int letter, here's my coffee. For int letter equal to 0. Letter haystack dot size. That's the maximum iterations we want to do. All right, we're now going to create copy letter. And the reason we are creating a copy letter is we will be modifying the value of letter. But if we modify the value of letter, so as I was saying, the reason why we're creating a copy of letter is because we are modifying the value of letter. And obviously, because we are using letter to iterate, continuously creating a loop, we do not want to use it directly. So we create a copy. And then once we grab our first letter, we then start grabbing letters from our second substring. In this case, needle. This is read as for character C in needle, do something with C. You don't have to call this C, you can call this I if you want, it's irrelevant. I'm using C because C stands for character. So char C in needle. If haystack at position copy letter is equal to C, then letter matches plus equals 1. And will increment the value of copy letter, thereby continuously looping. Right. And then once we're out of this, we say if letter matches is equal to needle.size, we return letter. This is the index of the match. Once we come out of that, if that didn't happen, we'll set letter matches back to 0. And let me just do a little quick check here. Let's clean up the space a bit. Okay. If not, we come out of the loop. There was no matches, we return -1. Right, that should work. Let's build and run. So 0 index, 5th index, and the 4th index. Let's go ahead and verify our code. So need does appear from the 0th index. Need again appears at the 4th index. Mississippi is sip appears at the 5th index. Right here, 1, 2, so 4. I forgot what index it was. At index 4. Yep. So 0, 1, 2, 3, 4, and then you read it as ISSIP, and that's it. We can make this a little faster, but I'll explain that in a second. This is our first working piece of code, and I believe it was this submission. Let me just check. Yep. This had a runtime of 0 milliseconds and a memory of 6.3 megabytes. I made a simple change. So everything here is the same, except I added a break statement. So if we go back here and we add an else break. A break statement breaks the first loop. So this if-else statement, this is not a loop, this is a conditional. The first loop is this one here. That would be your first loop. First innermost loop would be this one. So that's what a break statement does. It breaks the first innermost loop. And all this says is, if we are looking for letters, and at some point, haystack at some position is not equal to some character in needle, why are we still searching? We have to break it and start checking from the next character. And that's all. So if we go back here and we go to description, this is the piece of code that was my most recent submission. If we do run, we get that. And if we do submit, we get that. There we go. These are the two submissions, which is the exact same thing. And let's go description. I have this little piece of code comment here. Is this a replacement for string find? Now, I'll say it one more time. If the description does not tell you that you are not allowed to use something, use it. It's not your fault for a bad description. Next. If your argument is you should not use something that already exists, that's also fine. But by using your own argument, why are you even coding in that language? Why don't you code in the lowest level language? And that's all. Also, this code here, it may look a little different, but you can apply the same logic in Python. Except instead of using the braces, you would use that to indicate your function start, your loop starts, etc., etc. And you would read the function name as return type func name parameter list, which in Python it would just be define func name param list followed by colon and then whatever you want to write. And that's all.